This panel comes out of the Western Growers annual meeting. We work with our partners, S2G, the investment firm, and we had a tough choice to make. We had 80 applicants, over 80 applicants for 3 spots to come to Vegas. And as you'll hear in a little bit, not everyone goes to Vegas and leaves with more than they came with. But in this case, we did have someone leave with their pockets a little more full, which is excellent. So we choose, based on a presentation at Western Growers annual meeting, who the winner of that competition is, and we choose with our S2G investment partners who the 3 finalists are. So these 3 finalists made it out of a tough set of competition to get to pitch at the annual meeting to a bunch of Western Growers members. Did a fantastic job. We'll let them tell you how it went and how it went for them since then. And so each of them is going to present to do the same pitch that they did at the Western Growers annual meeting. We'll have burning questions. If you cannot wait, if you're worried about forgetting a question, we'll have a quick set of questions after each of the pitches. Then I'm going to bring all 3 of the AgSharks teams to the stage and take group Q&A from the audience. So we'll have a mic runner for any of the questions. So without further introductions, and I'm not going to bother introducing these guys, I'm going to pass the mic off to Alex from Ensolution, our first AgShark, and he'll take it away.
Hi, thanks for having us here. My name is Alex Athey, and I'm the CEO and co-founder of Ensolution. And what we're looking to do is to reinvent food safety with chemical-free technology. And we're very excited to be here at this Organic Growers event because of the nature of the chemical-free technology that we have, which is the deployment of ozone encapsulated in a nanobubble. We'll talk about why that's interesting and important in a minute. The problem we're solving is that of food safety. And we touch upon elements of as water use and also labor, because our solution's automated. And so we're not anti-chemical, I like to say. We're pro-solution. But chemicals are not getting the job done today. There's a lot of foodborne illness that still happens. There's a lot of recalls. Recalls are an incredibly expensive event that happens. If it's happened to your processing or growing, it can be an enormous expense. And so chemicals simply aren't getting the job done today. And what we're proposing to solve that with is ozone and ozone nanobubbles. So ozone's been tried many times before in the field of food safety. And the reasons that it haven't worked are exactly what nanobubbles provide. So nanobubbles encapsulate ozone. It keeps it in the solution, so it's not off-gassing and coming out to the workers. It is not as corrosive on your equipment as traditional chlorine dioxides or other sorts of things. And then also the nanobubbles allow you to supersede some normal laws of physics that allow you to get enough ozone in the liquid to make sure that you can do your sanitization and clean all of your products. So the benefits of this, you have a very powerful pathogen-killing agent, and it works very, very fast. Ozone's very, very fast as a sanitizer. There's no residuals left on the product besides oxygen and water. So I'll tell you a minute about the process. And I want to drill into this last point specifically at this conference. A recent sustainability survey by the Packer indicated that the number 2 thing that consumers wanted to see on their labeling as they bought packaging was the organic brand. The number 1 thing that they wanted to see was they wanted some indication of what chemicals were used in the growing and production of their food. And so this is important. You can say chemical-free sanitization with the use of our product. So how does it work? We take raw materials of air, water, and electricity. You put that into our vending machine-sized box, and we turn that into as much sanitizer as you need. So you no longer have chemical delivery costs, you no longer have storage, you no longer have dosing, because we've automated that. You automate that, and you can spray overhead, you can do immersion washing, you can use this in a number of places that we'll talk about. And because we're building this in a modern platform, we digitize over 200,000 data points a day that can go into your certification processes, that can go into predictive analytics so that we can monitor the equipment. You have choices. Well, the organic people have fewer choices for sanitization than conventional. But you have choices, and we understand where chlorine and chlorine dioxide, PAA, and automation of these things fit with our product. And we're doing very well in terms of providing sustainability goals, effluent concerns, lower customer cost, and you're independent of your supply chain. You no longer have to have chemicals delivered to you for sanitizing. You produce them on site. So we're currently working post-harvest pack house is where we started. And we'll talk about how we got started in 2 more slides. But we're already looking at irrigation opportunities and also distribution, truck washes and things like that. And this will become important as the new organic standards roll in, and you have to ensure that integrity of supply chain across the entire supply chain. Who are we? So I'm the co-founder, and my other co-founder, Lara Kirkham, and then a third co-founder that'll be shown on the next page. We've done a lot of things, and we cannot say the words. We're a 2nd generation, 3rd generation, 4th generation farmer. So we're new here, but we're here with an outside perspective that hopefully can create value and solve problems in the field. And one of the things that we do understand is the nature of interactions that the growers and processors have out here, and those family non-transactional things, but relationships that need to be produce value with new technology. We have a team of advisors that work on the labor side, on the food side, that have had experience in the industry, that have had regulatory experience, and these are all people that are advising us on a routine basis so that we understand how to build the product and value for your opportunities. So we've received $3.5 million from federal funding, and I want to talk about this for a minute. This is your tax dollars going to work. We worked with a very specific program called SBIRs, and a lot of this money comes from FDA. And if we hadn't gone and proposed this in collaboration with ideas from people in this room, we wouldn't have gotten this money, and we wouldn't be spending on an ag. It would have been spent on medical devices, probably. Most of our money came from FDA. We've had this money, and we're working to solve problems in this industry. And we have a very interesting piece of technology that produces the ozone nanobubbles that provide you that chemical-free sanitization. We have a number of partners. We're happy to talk about the partnerships and the commercial applications that we have, washing protein as it goes to market. We've done a number of trials washing leafy greens, apples, and oranges, as well as surfaces. And we get fantastic antimicrobial results on those. And we can take more questions on that later. So that's me. I'm Alex, and I'm more than happy to take questions now, or I'll be around the next 2 days. So I would be delighted to hear from each and every one of you. Thanks.
All right, so any burning questions for Alex? We want to move on. Yes.
Does it kill moss or anything in the irrigation system?
Biofilms, it'll remove the biofilms out of your pipes, which is a good thing. You want your pipes to be back to...
Is it legal now?
Yes. Ozone?
Organic?
Yep, it's organic approved.
Okay.
Generally recognized as safe by FDA. Approved for disposal on EPA on ground surfaces. Paul?
Post-application monitoring and testing, what kind of programs are in place, or is that a standalone or an add-on, or how is that testing and certification and verification happen?
So we measure every 6 seconds we measure the ozone concentration in the water that we're delivering. We measure the amount of water that's flowing out to the 1/10 of a liter. And we do all this automatic, and it's for free, and it plugs back into the systems of records of the processors that are using this.
You're currently using an ozone.
Yeah, we'll bring the mic back.
We're currently using an ozone operation or in our packing shed. Can your nano bubbles be adapted to the current operation?
Absolutely. So we know the people that seem to have adopted ozone, I don't know what you're growing and processing, but the Pacific Northwest and the apples growers have adopted ozone a little bit as an overhead spray, some of the peach folks as well. And the delivery, what ends up happening there is you don't end up delivering much of the ozone. It decays before it gets to the application area. This is amazing stuff. It stays in solution, and we can deliver 10 times the amount at 1/100th of the outgassing of the sanitization power at the application point, even through significant piping through your facility. But you'll gain if you're using ozone today, or if you're using just freshwater rinse, which you all have to use that if you're using an organic processing and your product goes through chlorine. If you're using freshwater rinse or you're using ozone today, you'll get amazing benefits by looking at the ozone nanobubbles. more. You can cut me off anytime, Walt. I'm going to be here all day. 1 hour for Alex.
This will be kind of quick. Does the use of nanobubbles versus kind of pure ozone prevent the need to upgrade the infrastructure on lines to Teflon, stainless, and other materials that are able to withstand the ozone, or do you have to do that upgrade?
You would still have to look at certain, Vitron seals versus your rubber seals, but most everything that we've seen that come in contact with the flume is stainless steel. That's all fine. Certain PVC is okay, CPVC is a little bit better, but anything that's corrosive, and chlorine dioxide is like 100 times more corrosive than ozone. And so if you understand what chlorine dioxide is doing, to dial it back, chlorine and ozone are very similar in their oxidation powers.
All right.
Oh,
One more?
one more.
Go ahead.
Does the use of nanobubbles decrease the need for a residual?
Which residual?
Like a residual, so if you're going to put ozone in a water wash system, you want to have some kind of residual at the other end to know that you haven't just had really clean water at that point, right? Is that what nanobubbles is doing, is reducing
Nanobubbles,
that?
yeah, and so I can talk about the residual in the water itself that you use for cleaning. This is the best way to measure if you've provided the opportunity for ozone to do everything it's going to do, and you can finally put enough ozone in the water to measure a residual. Almost always when you use ozone, it goes to zero because it all gets consumed immediately. So this will allow you to use the right amount of water if you're monitoring for that residual. Okay.
pH
Yeah.
doesn't have any
pH independent.
salts,
It can be a little harder to create the nanobubbles in higher salts.
calcium,
Calcium absorbs ozone, so sometimes on input water we
a higher rate offsets it or what?
we can work through certain calcium levels.
Sounds like you guys need to talk after. And I apologize. Thank you,
Thank you.
Alex, for that. I grew up on a fifth-generation family ranch about an hour south of here. I spent 30 years in Silicon Valley doing tech. I sit between ag and tech, and I'm the VP of Innovation at Western Growers, and my name is Walt Duflock, and my mom raised me better than to not introduce myself. I apologize. So that was Insolution, and I want to introduce the concept of AgSharks and how it works. Our role at Western Growers Innovation is to help these startups and our members interact better, more effectively, more efficiently. So these 3 startups, we're working with Western Growers and getting into market more effectively. And we look forward to working with some of you and these 3 startups to make those conversations, those field trials, those case studies happen better and faster, because when ag tech happens faster, my members are very clear they like the Western Growers Innovation team better. So help me, help you, right? So with that, I will introduce the second AgShark. And this is in a different space. All 3 of these guys are in different spaces. These folks are in different spaces. This is Tim from Swan Systems, and let's talk about water for a minute.
Thank you. Thanks, everyone. Presentation. My name's Tim Hyde from Swan Systems. We are a water management platform, water and nutrients. Originally from Australia, but been over here for the last 12 months. There's lots of challenges as growers, and it's coming from everywhere, whether it's politics, regulation. But these are the sort of some of the challenges we're sort of helping growers work through. So obviously the drought is front of mind in California. It's pretty serious on the West Coast. Staffing, having qualified staff's often an issue. The social license pressures. The customers are demanding that water and resources are used properly, and a lot of our corporate customers are sort of seeing some of that come through to the farm, where they're making quite sort of strong commitments on how they use water. And also, the reality is water management's quite complex, so there's lots of moving parts, so we want to sort of try and make that easy. So we call ourselves a digital bridge, and basically a transfer of knowledge too. So we want to help the farmer operate. We want to get all the data or get all the knowledge together, put it in one spot, and then help them implement across their business, efficient farming practices. Our focus is on generally production and profitability, but also sustainability, to do it in a sustainable way that meets your goals, whatever they are. We we don't sell hardware or distribute hardware. We work with lots of hardware companies. We've got great relationships with them. Like I said, our focus is on being a decision support, but yeah, it's 1 + 1 is 5. So if you bring all the sum together, what can we use that data for? How can we make the decision easier? How can we have that knowledge transfer to the business? So it's all about, what's out there. How can we make you do your job better and use the information that's available? The process starts with the aggregation of data, and then in terms of functionality, we schedule irrigations. So we model forward for the next 7 days. So each valve, that crop type, that root depth, that soil type, that stage, here's what you've got to do for next week. We can push that back into some of the smarter controllers, so we can actually sort of have, so you can schedule for unlimited valves, push it back into the controller and have the controller implement it. We can push it through to an app for the irrigators, or we can print a report and give it to the person. Annual allocation management, Sigma management is what we call it. Unfortunately, it's a bit of a different language to Australia here, but Sigma management is basically how much water comes out of each bore. We can sort of help you manage that and see where your budget to actual. We also help manage nutrients, so we can you can put fertiliser on in granular form, help you do your tank mixes, or actually we can actually account for water in the nutrients in the water. So mentioned before, a gentleman here, they've got calcium in their water. We can actually bring that in and work at how much calcium you're putting on. If you've got nitrates in the water, we can actually use that in the sum for the whole nutrient process. And the last part is sort of plant health. So we use satellite images. We can get the traditional Landsat and Sentinel, but we also bring in the daily imagery now. So that's a really functional tool for seeing how healthy your crop is. You can go back and see what happened for the last 2 or 3 days. You can pick up valves that haven't come on. You can pick up disease, water issues, or whatever's going on with the crop. So the whole thing is to give you complete transparency over every planting you've got and know exactly where you are every day. And reporting, so you can report budget to actual on different parts of the program. And you can also, we've got an impact module coming out, so you can report how many gallons of water to produce a head of lettuce, or how many pounds of almonds you can produce with a certain amount of water. So you can actually track and monitor that over time, so you can meet some of those sustainability goals and actually track and monitor that over time, so you can see the business getting better with time. So sort of how we help you. So we do work across the business. We generally sort of work with larger businesses, but the whole thing is to make the irrigator's life easy, so he knows what to do, or she knows what to do. We want to have the agronomists so they can implement, they can schedule easy, look at all the data. The ranch manager, he's got transparency. He knows, the nutritional plan's been implemented, the irrigation plan's been implemented. And then also corporately, we want to help with that knowledge transfer. We want to identify how to grow a good crop, lock it down in IP and make it repeatable. And the whole process is sort of building out what we call a crop library. And so that's exactly how you grow that variety on that soil, on that ranch, and make it repeatable. So that's our real focus, is sort of building out that corporate memory over time. So in terms of value for the business, we really want to help optimise usage, whether that's nutrients or water. We really want to make getting it right easy. Everyone remembers, if you're a grower, you've had a bad crop and what caused it. We want to look at a good crop, what caused that, and lock it down in that memory and make it easy, repeatable. Focus on profitability and margins and sustainability. We help manage risks, so risks in terms of climatic risks, weather, heat waves, but also HR risks. Also, you've got a good irrigator, he's been doing it for a long time, and he leaves. What does he do? Well, let's try and sort of get over that issue and lock it down. And also regulatory management, so the Sigma reporting, a few of those sort of things. There's more and more of that in Western markets. So, what can we do to sort of help that easier for the farmer? So, we're a functional platform. We work with any irrigation system or any crops. Where our focus is on helping you be better farmers and getting the benefits from a system like ours. So, happy to have a chat with anyone, but that's it. Thanks.
Perfect. Thanks, Tim. Any questions for Tim? Up in front.
I guess I'm the only idiot that wants to ask something.
Here, grab the mic, so everyone can hear the question.
Predicting your water use based on a weekly basis or a daily basis, or how are you predicting how much water use?
Daily for the week in advance.
Okay, but your ETAs and everything change during that week.
Yep.
How does that account for it?
That's what it is. It's a model. It looks at the crop, what its requirements are.
So you're looking at it daily then?
Yeah. We calculate daily, but model forward by day for the coming week.
Yeah, so you're predicting how much water you're going to use for the week and then adjusting.
Yep.
Yeah.
Yes.
All right. Good for now? Oh, thank you. Sorry.
Of course, we're in California and we often have water stress situations. Do you have any way to do deficit irrigation strategies in permanent crops?
I guess we're more the implementation platform, so we don't say, here's what you should do. So what we do is we sort of lean on or work with UCA, some of the work they've done. There's been lots for pistachios, how to sort of, what parts of the season you can have deficits. So we'd work with that data and sort of try and fine tune, but we wouldn't, sort of say, here's what you do. Yeah. Thank you.
Fair enough. Thanks, Tim. All right. And I just wanted to provide a little more context for the day. It's been a big ag tech morning, right? So we had biology versus chemistry next door with a great panel that Dennis Donahue led. We had the equipment panel outside with 5 innovative vendors. And I just wanted to give everyone 2 opportunities to keep the conversations going. Number one is in the trade show area upstairs. All of these, the 3 AgSharks finalists will be in the Western Growers booth with the Western Grower team. That's up the area. That'll be 12:30 to 4 after lunch this afternoon. The equipment teams will also be there. So anybody you talked to this morning, anybody you heard from this morning, we're all going to be upstairs for the afternoon and for tomorrow afternoon as well to keep the conversations going. And by popular request, because we heard a lot of requests for this already, the equipment area out there with the 5 innovative vendors, Carbon Robotics was out there, Pacific Ag Rentals is out there, FarmWise is out there, Fendt is out there, and Smart Spray is out there. They're all going to be staffed at lunch. So for those that want some extra time with the equipment folks, or were in a panel this morning, couldn't make it out, you get some extra time at lunch. So grab and go on the lunch and go hit the equipment folks up again, and then the expo area for this afternoon. So with that, I'm going to introduce the 3rd AgShark finalist up to the stage, and I'm going to give you guys a bit of context for what happened in Vegas, because the S2G team and the Western Grower team were very excited. What normally happens at AgSharks at the annual meeting is we get some finalists, we get some great presentations, the investor judges and the Western Grower judges deliberate, and we get about a $250,000 investment opportunity in a startup. At Vegas, things changed in a good way. So at Vegas, the judges went out and deliberated, had a tough call to make between these 3 finalists, and the team I'm about to introduce, sorry to steal your guys' thunder, exactly, and keep telling the rest of the story, they got a $6 million offer from S2G, our investment partners, for, I believe, 1 quarter-ish of the company. Super exciting to see that kind of commitment, that kind of interest level from S2G and from the audience. They were the People's Choice Award winner. They were the S2G Investment Choice Award winner. And so let's hear from the company that came back from Vegas with more than they arrived. That would be Nut Jobs with Paul and Marta.
There we go.
Perfect. Hi, everybody. Good morning. Thank you, Organic Growers.
You gonna drive?
I can drive, sure.
All right. Good morning, everybody. Pleasure to be here. We are really honored to be on the stage with these 2 other innovators, and that's the space we live in. So thank you for the opportunity to be here this morning. You want to kick us off?
Absolutely. My name is Marta Kephart. I'm the CEO of Nut Jobs, and this is our chief nut job in charge, my husband, Paul. And the Monterey Peninsula is our hometown, so it's really nice to be here. We are longtime growers. We have a native plant nursery where we grow about 800 species of indigenous plants. And I grew up on a strawberry farm in Poland, and some of my earliest childhood memories were looking out at that long row and trying to fill that bucket, the basket of strawberries. But a few years ago, we set out to start this new endeavor, and our single focus is to eliminate single-use plastic in our industries and to create formulations and technologies and products to meet that end use. And in order to replace single-use plastics in this industry, we focused on horticultural first because that's the space that we were in. And our next phase here is agriculture. And so our focus is to utilize and optimize secondary agricultural waste. And that's a benefit to this industry. We want to benefit farmers and hullers and shellers who have a lot of excess material. And we want to benefit manufacturers and seek alternatives for oil-based plastics, which we know are really prevalent, especially single-use plastics. And so what we've been doing is creating biocomposite alternatives for ag and horticulture.
Yeah, this is an immense problem for California agriculture and horticulture, and hundreds of millions of metric tons are in our supply chains. It's our own dirty little secret. For example, at our nursery in Carmel Valley, we grew some 5 million units of single-use plastic polypropylene pots for just one project. That was the Apple Campus 2. All of that's going into the landfill. And so this really stimulated our interest in packaging. And so that's what we share with you as organic growers is we want to create clean and healthy and safe alternatives to plastics. And we had a place to start. You know, our formulas are applicable to furniture or underlayments or anything that's blow molded or thermal formed or injection molded. But our advisors said, well, why don't you start in the space you're familiar with? And that worked out. As advisors, they gave us the right advice. And we were able to develop the patents and formulations for what we call the Alma pot, which is curbside compostable. The applications are broad, but this is singular for one large-scale producer, manufacturer of plastic pots. And they are pivoting in response to customer need as well as regulation. They're pivoting towards 25% of their offerings now will be in a compostable material. We've developed other applications for agriculture and horticulture. In our lab, we're trialing an Alma sheet, which is a sheet film for row crops. It has the same type of performance that a sheet film would have in that it protects the soil moisture content and keeps weeds from coming up into the crops. You can also inject your other chemicals or nutrients and water through drip tape underneath it. But the key here is we're not removing it from the field. It simply becomes a nutrient that can be dissed in at the end of the 9 to 10 month growing cycle. We're also developing the Alma pack, and that's on the books now in the labs, and that Alma pack is to displace what are the bubble wrap or the there are two things that we measure packaging performance criteria with, either impact resistance or thermal performance, and this formulation can do both. So we're displacing that bubble wrap kind of material in a mailer pack. Our lab is in Louisville, Kentucky, where the UPS is the international headquarters of shipping. So that's another focus of ours. But right now we have an order for 200 million pounds of our formulations, and that's just for that horticultural space. And Marta and I thought about this in terms of the business model, and that we really don't want to manufacture widgets or things. In order to make a positive change and really take on the problem on a global scale, we need to think about creating those formulations to solve your problems with plastics. So if you have packaging or other kinds of issues you're dealing with that you want to displace, come and talk to us, and we'll get to work on ideation and lab trials, and our formulas could be adaptable to nearly any kind of injection molding or blow molding or thermal forming. And that was one of the key elements of our patents, is that we're able to create parity between polypropylene and polystyrene, and also with Marta's help in terms of the financial modeling and our supply chain partners, we're getting parity with price. And that's the other thing. If we want to change the world and become more sustainable, it has to be economically sustainable, not just environmentally sustainable. So that was a real key goal and objective of ours.
Yeah, so in the last couple of years, we focused on our patent portfolio. We have 4 patents that have been issued now to us, and with continuations in part open so that we can continue building our patent portfolio. And here's just a few examples of some of the testing and trials that we've gone through. What we're really excited about at the bottom too is our Almalose formula, which is really almost like a styrofoam alternative, which is a really great alternative for your traditional packing peanut and anything else that needs any kind of performance regulation in terms of shipping containers. And in terms of our value proposition, and the bioplastic space is filled with a number of competitors, and where we really differentiate ourselves is we're in the upper right-hand quadrant. And so not only are we bio-based, but we're also at a price point where we can be competitive with traditional bioplastics. And that's really been one of the biggest barriers of entry to be competitive in the single-use plastic space. Most traditional bioplastics are 3 to 8 times the price of traditional plastics. And by using our nut formulations, we can really, which have a lower cost, we can really push our formulations to be financially competitive.
So our process is we're working directly with the huller and shellers. We have mobile modular units that grind and dry and compound our formulations. So in order to be sustainable, we're shrinking that supply chain. We don't intend to ship that waste material anywhere. We want to convert it on site. That really helps us with our long-term financial model and our capacity to scale. And from there, we're working with the largest bioresin producers in order to create, and not only to answer the demand, but create more demand. We're working with them. And there's PLA producers, PHP producers, corn and sugar and canola oil, PHA, that we've used all of those on our formulations for different applications. So that's us in a nutshell, and we'd love to take your questions.
Yeah. Thank you.
How long does the first product you had, your plastic, how long does it survive?
9 to 18 months, and we can adjust.
Do you make anything that lasts longer, like for
we
nut crops?
We certainly can. We can control that with the density of the resin, and then we can also control that just by the compression molding application.
And it's allows the penetration of water through it, or you have to put drip hose under it?
Drip hose under it.
It won't penetrate from the top.
We're in the lab right now. We're working through that.
You mentioned strawberries, and you mentioned a little bit of plastic to replace the mulch that we're using currently in the industry. I'd like to see some of that. I'll go upstairs and see if you guys have some of those materials. But my question to you is, how difficult has it been, the approval on adhering to the NOP ruling, to have your product being utilized by organic growers? And
that's a real key issue here. We have, unless we use organic hull and shell, then we have pesticide residues we're going to be dealing with. So that is going to be one key issue and hurdle that we'll need to, and challenge we'll need to cross. Especially as we get into any food grade applications. Like we've already developed plates and knives and spoons, and that's typical kind of food grade applications you see for pulp or fiber or other cellulosics. But you know, that'll be key for us. We've just reviewed all the pesticide residue in reports, and unless we go with the certified growers, we'll not be able to use that as source material. Another challenge, another hurdle that we'll cross.
Hi, this is really exciting. One, because I'm an almond grower, and two, because I'm on the almond board on the biomass committee. And this is exactly what we've been sort of dreaming of for years with our almond shells. So I have a couple of questions. Is there a price point with almond shells where it makes it more difficult for you? I mean, because I like the idea of this being a circular economy in California where you guys gain and we gain. And then I just texted my guy at the almond board. He wanted to know the technology. Is it involving thermal conversion, or it's an enzyme, right? Or
it's not an enzyme.
Oh, it isn't.
It's
okay.
compounding.
It's compounding.
Very simple process.
Okay. Thanks.
And then to speak to your other issue, and that's what we're facing now with Hull, that price, it's mercurial, and it's based on the price of corn and hay and water availability. And because it's used as a filler or a cellulose in cattle feed. So it's the hull, not the shell? It's both. So, but what we're doing is now the hull has those sugars and oils that also acts as a plasticizer. So we get some benefit, lower melt temperature, faster flow rates through the equipment, lower energy costs. So there's some interesting correlations there. But the price is, you know, from what is shell now, anywhere from giveaway to $65 a ton. You can't afford to haul it. And so our new focus in that polystyrene alternative is nearly 100% shell. And that's really good news for a lot of us. And what we really have focused on is price parity. How do we get to where we can compete with polypropylene or polystyrene on that monthly index? Not an easy task. Good question, though. Yeah.
Hi. With Sigma coming into effect and legislation kind of looking to fallow close to 1 million acres, how do you see that impacting your business model in terms of availability and price?
Yeah, I think it's a good question, and it also tags on to the last question. In our current model, if we meet our 5-year production targets for our pellets, we're only utilizing 5% of the available feedstock in California alone, and that's only for almonds. And if we further develop product and formulations out of pistachios or other nuts, or look at other growers elsewhere throughout the world, I think we're still not going to move the needle in terms of utilizing that full feedstock.
And then like hemp or mycorrhizal fungi or chitin or other feedstocks, this is scalable. And that was something that S2G looked at in our business model, is our feedstocks and the availability and pricing in order to scale the business.
Yeah.
That
and
was
the centralization of the feedstock as well. Mm-hmm. Yeah. Thank you.
Thank you.
Can you blow clear film? And if so, is there...
That's the holy grail.
That's the holy grail. And
Nuclear fusion.
well, we can do translucent, but clear film is another space. That's where you start to get into PHA and PHB, which you know, you can buy clear film now. It's just that it's very expensive. It's like $6 to $8 a pound, and we need to be at 90 cents.
Yeah.
So it's not the space we're in. We're going to be in this horticultural, agricultural packaging, which doesn't have that requirement.
Thank you.
All right. Well, with that,
Thank you.
Thank you,
Let me,
everybody.
thank you guys.
Thank
No,
so
great.
much, Walt, for having us. Thank you.
I'm going to invite Alex and Tim to come up on stage, and now we have 20 minutes. You guys stay, grab a seat. And now we've got 20 minutes that we didn't have at AgSharks where the audience gets to ask questions of anybody. And I'll actually start with this one as the audience gets ready for any questions they didn't ask yet. Next 2 years goes well. We're grabbing a beer in November, December of 2024. What's that look like? You guys first.
Go ahead, Marta. Next 2 years.
Oh, and I would say in our next 2 years, I would love to see the horticultural adoption of our pots. And I would love to have trials and test plots of our weed stop alternative. And lots, lots, you know, lots in terms of, I would love to be in a place where we could say with confidence that we were able to be at parity with traditional single-use plastics.
Yeah.
Yeah, I think that's the number one goal.
No, it's a great goal. Great vision. I like it. Tim?
I think we'd like to be working on, working with lots of growers in California and bringing value to their businesses. We've got ambitions to have several million acres on our system in the next few years. So hopefully we can bring value and we meet those goals.
Nice. Alex?
Success in 2 years, we would still be here. You know, the existential nature of being a startup company is
truth.
And for us, you know, I've worked in a lot of different technology and sectors, and I've worked for the Department of Defense, oil and gas, and the wholesome nature of working in food and providing food, and the critical nature of food safety, right? Like, and so we have this metric, and it may feel corny, but it's real, and it's like, if we can prevent one foodborne illness outbreak, you know, one person, it'd be worth it for us, you know, to have done all of this. And so, you know, that's what we're committed to doing, is to pushing this out, getting surfaces, product, anything else cleaner that we can, because ozone's a fantastic sanitizer, and it decays back and, you know, has all kinds of environmental benefits downstream. So, still here.
Great answer. A real answer. All right, so we've got a few minutes for you to ask this panel, and I just think this panel does such a great job of representing where ag tech is. Yes, it's the robot weeders and the laser weeders that are outdoors, and it's the new Fendt tractors and the sprayers and FarmWise, but it's also ozone nanobubbles, and it's also nut byproducts, and it's also water efficiency, and we heard Sigma. So I just think this show represents a really nice cross-section, and this panel a really nice cross-section of ag tech today and where it's going. So we open it up for further questions. Anybody have any questions about the business models, about the products? Anybody want to engage these guys in some conversation? Let's have at it.
Good morning. When will you be profitable, each business?
Are you asking all of us?
Great question.
Yeah, so I think what I see all the time is we're building, we're innovating, we're building, but they didn't put $6 million to you. Well, I could ask that too. How much fun was that day? But when will you be profitable? I see the visions.
Yeah.
Okay.
Well,
So
talk to your pro forma.
yeah, so we're going into production in the second quarter of next year. And we have a 5-year runway with our first customer. Our use of funds for this investment really is just to scale up our facilities to be able to compound our pellets on site. And so we're looking at a break even at the end of the 2-year runway. And that's really only focusing on our first customer.
And the 2 products?
Mm-hmm.
Oh, me next.
Nothing you're committing to, Tim. This is just on stage.
It really just gets it gets down to how hard we're going to put our foot on the accelerator on the gas, really. And we'd like to think we'd be profitable in 2 to 3 years. We tend to take a while to get a customer. We work with them, and then they scale across their business. So it can be a 3 or 4 year process. And we've got three publicly listed companies now scaling our product across their enterprises. So, but it just takes time to build confidence. Takes time to make sure they get the value out of it. But yeah, I'd say 3 years probably. We'd probably try and be cash flow positive. Yeah.
Yeah, and I think it does highlight the most of the people in this room are grower processors. There's a few ventures sort of in the room, and ventures sort of striving for that massively profitable, right? So they almost want you to dip down hard on cash and then rock it back up. And that's one of the challenges of working in venture-backed things. And so we've been focused on I can simultaneously love risk but be averse to ruin, right? And so I try and balance those ends of the barbell. And so we're very capital efficient right now because we've had to be. And so we have different versions of our model where we could be cash flow positive in 18 months. We have another version where, depending on who wants to invest and how big they want that slope to be on the other side, it could take, maybe 36 months. And then, you rocket out of that, and in 5 years, you're in substantially different places. So it kind of depends when you're a startup company and where you get the money from, and what their stakes are and what they're driving towards, right? And so I think one of the interesting things that Western Growers is doing is pulling people together and teams together and saying like, hey, does anybody in this room want to partner with ag companies, ag startups? Let's get a better product and do non-traditional funding. But I can't go to a bank and say like, hey, I just invented something. Want to loan me some money? That doesn't exist. And so only certain types of capital are available. And so I think that's the challenge for everybody in the room is how do you get things like this into there and have us exist on the other side of this? And it's a dialogue.
And the one thing I'll add is I work with a lot of startups, these days all ag tech, and I just want to remind the room that every startup that we work with, a lot of them didn't make it out of COVID, right? If you were selling a solution that was heavy food service and we shut all the restaurants down, how'd that work out? So I found myself given a lot of really interesting and unfortunate advice in 2021 and even parts of 2022. Survival, to the extent you can do it, is a competitive advantage because those that don't make it are no longer competing with you. And that is part of the ag tech reality. So these guys all make great points, right? Depending on the business model you have, but also depending on the macroeconomic around you, that answer can change to when profitability shows up. And I found a lot of startups doing really what you'd call creative things the last couple of years to make it out the other side. I give them full credit. There were a lot of tough decisions getting made the last 2 years in ag tech land. Sorry, not to go Debbie Downer. Next question.
This is just pure curiosity on my part. This is for Alex. You mentioned you took funding from FDA. Does that come with extra reporting requirements or encumbrance that may make it more difficult to raise private venture funding in the future? Because it's public money, so what happens down the road?
So we're working with the government. So yes, it did come with extra reporting requirements, but it makes us more attractive in some ways because we did the hard part, right? Like they talk about in venture 0 to 1. There was nothing and then there's something, right? And so we now have something. And so 1 to 10 is a much easier process to understand how we get from one thing to 10 things. And so we did the hard part. Bootstrapping, and again, these were very competitive projects that we solicited for and submit proposals to. But we don't. The government doesn't own anything. Doesn't own any IP. This is a very specific program that's loved across both sides of the aisle, where you take a proportion of every agency's budget and you designate that it makes sure that it gets out of academia and back into the real world. So that's what that money is sidelined to do. It's about 3% of every agency's budget has this program. So we got USDA and FDA.
Yeah, and I would add to that, working with a lot of startups, a common source of funding is what's called non-equity, non-dilutive funding. So SBA, Small Business Administration, actually offers small business innovation research funding. Work with multiple startups who've applied for those grants, work with multiple that have gotten those grants, multiple grants in some cases for $250K up to, in the high end, $1.25, I think it was. That is awesome money for startups if they can get it, even with the reporting requirements, because it does not hit your ownership table of the startup, right? So when we get to the chance to work with startups who are coming out of university phase, research phase, we frequently point them to that application process, because the number one thing you want to do when you talk to S2G is say, my cap table looks fantastic. My ownership table is basically the team and nobody else. So big advantage. Are we that hungry? We're ready to break for lunch? I'm giving you guys access to some of the brightest minds in the building for 8 more minutes.
And me.
And Alex, exactly. He was the filler.
I have to know who came up with the name Nut Jobs. and a little story behind that, please.
Yeah, that would be me. Yeah. I just wanted to add on about this network. And something really wonderful happened in Las Vegas. Not only did we raise that $6 million, but one of the Western Growers Association members just tagged on and finished our round yesterday. And it was based on that network and the shared vision, and we're really pleased we got it done yesterday. But it was because of that network, and what we're finding is this is the way we're going to solve problems together, is that if we have these certain issues we're dealing with and our production efficiencies, our materials, then we work together. And on companies that are in the startup phase, we want to solve those problems. So you heard from these guys today is they have great solutions for some of these issues, and that's how we'll get the job done.
No, congrats on the close. It's awesome news, and we're happy to be working with you guys, all you guys.
It's actually been a lot more work than I had envisioned. And having come from a ranch and farm background myself, I've not done nearly every job on a farm and a ranch. It was a lot more work.
Yes, ma'am.
How long did the development of the science and the engineering take? And then were you working with the university, or was it all private?
We
started
worked
in
with
2019 in the
with
summer.
Warner Babcock Institute, which John Warner is a green chemist, and they're in Massachusetts. We also worked with Lowell, which is the Plastic Innovation Institute, to do our original compounding trials. But I had done all of the precursors to the formulations in my own lab and developed those to a point where I could turn them over to a chemist, and then we tested all the compounds and the structural, chemical, and physical performance indices. We did not choose to work, for example, Bill Orts has done some work in the Albany lab. He had developed some compounds, but he used something that, as an ecologist, I would never do, is he compounded typical oil-based polypropylene with that waste, which, is taking a biological nutrient and an industrial chemical nutrient and combining them. And so that's something that's why we're in that upper right-hand quadrant. But it took 2.5 years of some heavy lifting. We did raise about $800,000, friends and family. We had great advisors, and all of that money went to our patents and to the formulations and the development of the technology. It was not an easy lift to get to a material that could perform at the temperatures typical polypropylenes and polystyrenes flow at, because we'd burn it up. And so that was something that was a really interesting exercise, and we were able to overcome that challenge.
Well, I'm interested in talking to you more afterwards.
Sure, love to.
And I should mention, you brought up a great point. Almond acreage is leaving places in the southern San Joaquin Valley. The estimates are from Sigma, and I don't know if someone mentioned this earlier, how much, but it's 1 million to 2 million acres of lost production in the San Joaquin Valley. And with apologies to folks who mentioned this, like PPIC, you don't want to just put all those 2 million acres into solar panels. When you lose those 2 million acres in the San Joaquin Valley because of Sigma, that acreage relocates. That acreage also relocates ag tech, right? If you think about asparagus, when I was a young lad, we had 60,000 acres of asparagus, we had pack houses in the Imperial Valley, and we had a thriving economy based on asparagus, packing it, and all the tech with it. Now we have 600 acres, and if you talk to Neil Callis at Turtle Rock Fruit, one of our board members, he will tell you the asparagus automation folks, they'll get to him when they get to him, right? Who do they answer first? The other 59,000 acres that have moved on. So those of you that have influence with the elected officials and some of the folks making decisions in Sacramento, agriculture decisions affect where ag tech companies and jobs operate and scale. Soapbox down. Questions?
Okay, maybe I'm the only person in the room who doesn't know the answer. Can you give us some basics on how the nut shells and insides get turned into this material that you use for these replacements?
You know, as an ecologist, I practice something called nature-based designs, and much of our work looks at analogs in nature as a way in which to inform design. And I see these as solutions that we actually designed plastics to be toxic, right? We designed them to perform the way they are. And so when I look at this is how I started. The question was, what's the perfect package in nature? And a friend of mine said, oh, it's the eggshell, you know, that protects the embryo and lasts until the chick hatches. And I thought about, well, it's pretty fragile. And then I thought about the nut and the shell. There's the criteria: impact resistant, and the fibrous hull, which is thermally protecting that embryo, the seed, and the nut. And I took those two things apart and simply compound them with other bioresins. Like, very obvious, very simple, but as a really long-term mentor and farmer friend of mine said, the obvious is the most elusive. And that's how I came up with the idea. And I've talked to people that have been in compounding of plastics and bioplastics work throughout the world, and they're pleasantly surprised and happy for a new alternative. Now, it's not the end all either. There's fibers, cellulose, and other materials, pulp, paper, that we can compound. But the future of plastics is really in this compounding. You know, we're going to use fiber, for example. We're going to use pulp. We'll use wood chips. And we just happen to have a lot of cellulostics and nut waste in the performance. It works. It works in the equipment. It works, you know, from a lot of different testing and performance standpoints. And we can roll it out in a sheet. It's actually, when you touch it and feel it, it looks, feels, acts like plastic, but it's not plastic.
And just from a practical standpoint, we take the hull and the shell, we dry it, and then we grind it. It's almost like a flour, and then that's blended together with other plastic, bioplastic resins, and with some heat turned into a little pellet that can be 3D printed or injection molded or thermoformed.
Does the nut act like just sort of like filler, or is there a chemical reaction that takes place between the bioresin and the
both?
Yeah, we don't use the nut itself. Okay, so that's the seed. We use the hull and the shell, and we separate those, and in some formulas we commingle them. But does it act like a filler? That was my original thought. Gee, this is just a really inexpensive way to get the cost of bioresins down. And then when we conducted all our tests and put it through the patent attorney's language, it actually enhanced the plasticizing performance. So it became a plasticizer, not just a filler, which was a key component of the patent application. And I'll mention another benefit of being slightly over 65 is when you go to the patent office, they give you an expedited process. So
Just in case.
3 months it takes now, and we've left all of our, the value of this company is in its IP right now. We have 4, and we have what's known as a continuation in part. So we have the patent that says agricultural waste materials for single-use plastics, big, broad patent. Now we have the Almapot and then the Almapack, and that's the continuation. And so we are, in the lab working diligently around the clock to develop the formulations around these new applications for the material. And that's all part of this business model. And I think that was what was attractive to the investors we've talked to is, the value is in that IP, but also in the potential growth of that IP.
We're not yet recommending that every patent application include a 65-year-old, but you see the benefit. And no word of extra expedition for blood pressure, if it's a little, we get to that point with the patent office? Yeah. All right, well, folks, it's been a great hour. Thank you for a great conversation. I want to remind folks the equipment vendors will be available during the lunch hour. So next up is lunch out in the foyer. And I would invite everyone to come to the trade show area, afternoon discussions with these folks and other ag tech vendors. We'd love to keep the conversation going. Let's give one last send-off to the AgSharks.